So by the uniqueness theorem, we've satisfied both conditions. They have the same derivative, they share a point, they are the same function. So by uniqueness theorem, the natural log of a divided by b is equal to the natural log of a minus the natural log of b. All right, one more proof. And it's a little bit more complicated in the algebra stuff, the exponent stuff really. Otherwise, same process. Prove by uniqueness theorem that the natural log of a to the b equals b times natural log of a. So that exponent being the multiplier. So again, first thing we do is identify each side as a separate function. F of x is going to equal the natural log of a to the b. G of x is going to equal b times natural log of a. Again, a little premature because I don't have any x's in here, but we're going to do that now. We are going to let b be the constant. So treat it as a number. We're going to let a equal the x so that I get a function in terms of x. Rewriting f of x, just in place of the a, I'm going to put in an x. So it's natural log of x to the b. G of x is b times natural log of x. All right, now we're ready for our two-part proof. Show that they have the same derivative. So f prime of x. Okay, I cannot use the power rule because I haven't proven it yet, so I have to leave it just like it is. So it's a natural log. The derivative of a natural log is 1 over the u times by this derivative. Well, think of it as a number again. Say it was x squared. What would you do for derivative? You would bring that down as a multiplier and subtract 1. I'm going to do the same thing. The b, treat it like a 2. Pretend there was a 2 there. You'd bring that 2 down. I'm going to bring the b down. I'm going to subtract 1 from it. Well, I've got to go b minus 1 because I don't have a number that I can actually subtract 1 from. Okay, now I'm going to simplify this. So I'm going to first bring them together. So I've got b times x to the b minus 1 over x to the b. Okay, so I've got an x term divided by an x term. Remember the property that I'm going to use is I get to subtract exponents. So it's this exponent minus the bottom exponent. So I'm going to take the time to write that. B stays, x to the b minus 1. Then I'm going to subtract this bottom exponent of b. Okay. Simplifying this out, I've got b minus 1 minus b. Well, the b's are going to cancel each other out. And I'm left with x to the negative 1. And remember, that's just an unhappy exponent. If I put it back in the bottom, now it's happy again. So I get b over x, or I could have left it here. Made the other one look like it, but I made it a happy exponent. Over here, derivative. So remember, the b is a multiplier. Like if I had, oh, it doesn't matter. You just carry that along as a multiplier. So it's b times this derivative, which is 1 over x. This one was easy. It's b over x. So same derivative. And now I have to show that they share a point. Show that they share a point. And there's always a trick. The first one, we let x equal 1. The second one, we let x equal b. Here, we're back to letting x equal 1. So I want to go back to function f and find out what the y value is when I put 1 in for the x. So putting 1 in for the x right here, the natural log of x to the b. I'll get rid of that 2 that I had there. So that's the natural log of 1 to the b. Well, 1 to any power is still just 1. Natural log of 1 is 0. So we got the point 1, 0. When I put x as 1, y came out as 0. For g of 1, we better get the same thing. So g, I'm putting in 1 for the x, keeping the b. So it's b times natural log of 1. Well, natural log of 1 is a 0. Anything times 0 is 0. We just got the point 1, 0. I've now shown that they share this specific point. So by uniqueness theorem, the natural log of a to the b equals b times the natural log of a. Okay, you are going to have to regenerate these 3 proofs. We'll practice them tomorrow in class. The homework I'm going to give is just using these properties, and it's from my old calc book from college. So I'll do a couple of examples to show you what's going on, but nothing too challenging here. Just grabbing some more paper. I ran out. Okay, I'm going to show you the problems real quick. Yeah, I didn't do logs until chapter 7 in calc, which is in calc 2. But that's okay. So we're going to start actually here. This first chunk of problems is actually from yesterday's notes. It's that given function f is the antiderivative thing, find the derivative. So this is just that shortcut where you stick the x in and then multiply by the derivative of this. So I'm not going to do any of those because we did those yesterday. We're going to skip the sketches. Right here, I want to do these ones in here. It says, use the properties of logarithms and the fact that the natural log of 2 equals 0.6931 and the natural log of 3 equals 1.0986 to approximate the given logarithm. So I'm going to do 2 of these to show you what's going on. So we're pretending we don't have a calculator here. The only 2 logs you know are the natural log of 2 and the natural log of 3. And they want us to evaluate, let's say, the natural log of 24. Knowing only these 2 logs. So, if I think about it, around 4. The natural log of 24. What I want to do is rewrite 24 as I want to rewrite it as the product of something with 2's and 3's. Well, I know 24 is 8 times 3. And I know that 8 is 2 to the 3rd power. So 2 cubed times 3. 2 times 2 is 4 times 2 is 8. 8 times 3 is 24. So I've just rewritten the 24 in terms of 2's and 3's. And now I'm going to use that property from logs that says if I have the log of a product, I can expand this to the log of a sum. And now I can bring this down as a multiplier. 3 times the natural log of 2 plus the natural log of 3. And now I actually have these 2 values in the book that they gave me. So it's 3 times 0.6931 plus 1.0986. So if I check that out, just going to type in what I have there. 3 times 0.6931 plus 1.0986. I get 3.1779, and that's supposed to be the natural log of 24. And you can see I've got 3.1781, 3.1779, and that's because these end numbers are rounded off. So yes, I did do it correctly. So that chunk, your goal is to rewrite the number they give you in terms of 2's and 3's. I want to do one more, so you get the hang of it. The natural log of 1/72. Okay. Okay, 1 is not a problem, because I know the natural log of 1 is 0. The 72 has to get rewritten in terms of 2's and 3's. So I'm going to go with That's 9 times 8 is 72. 9 is 3 squared, and 8 is 2 cubed. So I've got 1 over 3 squared times 2 cubed. So now I'm going to break this apart so that I've got natural logs of 2's and 3's that I can substitute those values in for. First of all, to undo this, I've got a division, so that goes to a subtraction. Natural log of 1, subtract the natural log of this product, 3 squared times 2 cubed. At this point, if I want to put a 0 here, I can. But now this gets expanded to a sum, and I've got to subtract the sum, so I do need a set of parentheses here. So it'll be the natural log of 3 squared plus the natural log of 2 cubed. These can come down as multipliers. 2 natural log of 3 plus 3 natural log of 2. And I have these values that they gave me in the book. 2 times 1.0986 plus 3 times 0.6931. And if I check all this out, let's go. 2 times 1.0986 plus 3 times 0.6931, and I had a negative in front of that, so I get negative 4.2765, and if I check the natural log of 1 divided by 72, negative 4.276667, so right in the ballpark. Okay, so that's that chunk. And then the last two chunks, and this we did before when we had those worksheets, it's just practicing. So on this next chunk, the 25 to 34, you are going to be expanding these as much as you can. I'm not even going to write one down. Like this one here would just go to the natural, I'll go this one, natural log of x plus natural log of y plus natural log of z. So expand these ones as much as you can. Here, you're going to condense them as much as you can using properties. I'll do one of these where we condense. I'll do number 36. So that's my last example. This is your number 36 that's on that work. It's going to be on the worksheet. Starts out 3 natural log of x plus 2 natural log of y minus 4 natural log of z. Okay. First, going to simplify each one by bringing these multipliers up as exponents. Then I have to start from the beginning. I do the adding first. So when I add, I multiply. And when I subtract, I divide. So I'm going to have the natural log of x cubed y squared divided by z to the 4th. Okay, so it's just good practice with those properties again. Okay, your assignment for tomorrow is going to be to redo all 3 proofs. And you're going to do the odds 7 on this worksheet, 7.1 worksheet, 7 through 39 odd. And you're going to skip the graphs that are at 11, 13, and 15. Okay, there's that.